Hi everyone, in this video we will learn about some common system design patterns used in the context of microservices, namely Saga pattern, compensating transactions pattern, the orchestrator pattern, and the choreography pattern. So every system design pattern that has been created is trying to solve a problem. And these four design patterns are mainly used for solving problems around distributed transactions. So let's first understand what distributed transactions are and how these design patterns solve the problems related to distributed patterns. So let's first understand what is a transaction. You must have heard of ACID properties in relational databases. ACID stands for atomicity, consistency, isolation, and durability. So basically, a relational database is supposed to follow ACID properties, and a transaction is something that provides those ACID properties to the relational database. So what is a transaction in a database term? It's a logical unit of work that represents a series of one or more operations or actions that are performed in a database or in a distributed system. And the main purpose of a transaction is to maintain the integrity and the consistency of the data that has been stored in the database. And a transaction includes operations like inserting in a database, updating, or deleting records. So, if any part of the transaction fails, all the changes made by the transaction should be rolled back. And that is what a transaction uses to ensure consistency and integrity in a database. And that is how a database returns to its original state and consistency is maintained. Now, let's understand what is a distributed transaction. So, any transaction geographically distributed is called a distributed transaction, meaning in the previous slide, we understood that a transaction is something related to operations in a database when multiple tables are involved. A distributed transaction is one in which a transaction involves operation spread across different components that may or may not be geographically distributed. Mainly, these resources can be databases, microservices, message queues, and other distributed systems. And the operations are executed across multiple nodes, and all these operations are treated as single logical unit of work. So basically the purpose of distributed transaction is, as said about transactions, distributed transactions also ensure data consistency and integrity across all the participating resources, even in the presence of failures or network disruptions. So let's try to understand what distributed transactions are with the help of an example. Let's take the example of an e-commerce order processing. So what are the steps that are performed while we place an order on a website? Firstly, the application receives details from the customers and creates the order. Then in the backend, the some service tries to reserve the inventory that we are trying to order in the database. Then a payment is made from the customer's payment method, whether you choose a credit card or a debit card. And then once everything succeeds, the payment is successful, then the customer is notified after few minutes whether the order was successful or failed. If we convert all of these into different microservices, then this is how it will be looking. Firstly, we'll have an order processing service that processes the order for the customer. Then we'll be having an inventory update service which goes in the backend and reserves or updates the entry in the databases. Then we'll be having a separate service for the payment option. And the final service would be there, which is responsible for sending notification to the customers once the order is successful. So let's understand what could be the problem in the case of a distributed transaction. For example, place an order. The order went successful. Then we went ahead and updated the inventory. That also went successful. But when the customer was doing the payment failed. Now what will happen? The inventory has already been reduced. The order has already been placed. Now what do? We need, since the payment failed, now we need to roll back the update made in the inventory, and that is what needs to be done. So there is some rollback that need to be happened for a previous service, for a previous transaction that was successful. So we need to do a rollback for the inventory and if required for the order processing service. Now let's see what the Saga pattern is and how it will be solving our problem. So the Saga pattern addresses the challenges of handling long-lived transactions that span multiple microservices, as we saw on the previous slide. Each microservice is executing a specific operation and emitting events. The events or the transactions, the sub-transactions are divided into series of smaller transactions, and these transactions, sub-transactions are called as Saga steps. And as we talked about earlier, this process, this design pattern is used for ensuring eventual consistency. Like at any given state, all these services might not be in a consistent state. For example, there was a state when the payment was failed, but we had the previous transactions in an inconsistent state where they had updated the inventory. So they may stay in an inconsistent state, but eventually they would they would converge to a consistent state. So what the Saga pattern does is if a transaction is successful, we move to the next transaction. If the transaction fails, then a sub-transaction is executed that nullifies the effect of the previously succeeded transaction. And these sub-transactions that are used for rollback are called as compensating transactions. So now let's see how the Saga pattern internally works. So the Saga pattern consists of two parts. The first part is the coordination of sub-transactions. So as we saw in the previous slide, there are a number of microservices involved in executing a distributed transaction. Now, some mechanism has to be deployed in between, which ensures that once microservice A has done its task, then microservice B has to get started and then microservice C. Someone has to do the coordination that microservice B does not start its work before microservice A. So Saga pattern gives us a design which ensures that the coordination of sub-transactions happen in a proper manner, and we do that using one of the two patterns, which is the choreography pattern or the orchestration pattern. We'll learn about both of these patterns in the coming video. But this was the first part of what the Saga pattern does. The second part, what the Saga pattern does, is ensuring data consistency. So how Saga pattern does it? Because the basic foundation of a distributed transaction is that it has to ensure that the data remains consistent. If there are multiple databases involved or multiple microservices involved, the data has to be in a consistent state. It should not be that a payment has failed and the inventory has also incremented. We did not reduce it back, like we did not update it back to a previous successful state. So Saga pattern ensures that, and how it does that is using compensating transactions, and this is also a design pattern in itself. So we'll learn about compensating transactions pattern also, but this is how the Saga pattern internally works. Try to understand what compensating transactions are. Let's take the example of booking a seat or booking a ticket in movie theater. So when we go to bookmyshow.com, we select a seat and then try to make payment. So let's consider a success scenario where the booking of the seat succeeds and the payment also succeeds. So in this case, everything is fine. We get the invoice at the end because it's a successful transaction. So everything is fine. But let's consider a scenario when the booking of seat was successful, but the payment failed. Now what? Now there is a consistency between the seat has been booked, so we have already reduced the count of seats by 1 or 2, by whatever the transaction was, but the payment has gone unsuccessful. Now if we don't do anything at this stage, then at the end of the day we'll have some booked seats without any payment, and eventually at the end there would be no one turning up to the movie theater to watch that movie on that seat. So that is an inconsistent state, and we want to avoid that. So what do we do here? We make the use of compensating transaction. So what is the compensating transaction? When one a part of a distributed transaction has failed, then we create a rollback transaction. Basically, we create a sub transaction that nullifies the effect of a previous successful transaction, sub transaction, and that is how we ensure consistency. So compensating transaction is basically a sub transaction that is executed to nullify the effect of previously succeeded sub transactions in the main transaction. So compensating transaction is actually a design pattern. It can be used separately. It does not need to be used always with Saga pattern, but it's a design pattern itself. But Saga pattern also uses it internally. Now that is how Saga pattern ensures data consistency among the microservices. Now let's understand how Saga pattern ensures the coordination among transactions. The first option in that for coordination of microservices is implementing Saga with orchestration. So in orchestration, there is a central coordinator service which is called a Saga orchestrator, which is responsible for managing the entire transaction. Like as I said before, there are multiple microservices. How does a service know that I have to execute after service A or after service B or before service C? So there is a central service called the Saga orchestrator that is made to sit between them, and that is responsible for ensuring the coordination among all the microservices. For example, in the case of e-commerce order, let's example there is a central service that's the order processing service. There's an inventory service, payment service, and the notify customer service. So as you can see in the diagram, there's a central service, that's the order processing service, that is sitting in between all three services and ensuring that all these microservices are coordinated amongst each other. So the orchestrator, the central order processing service, actually when an order is placed, it sends command to the relevant services and controls the flow. So when an order is placed first, so the order processing service would send an even basically a command to the inventory service. Now once the inventory is complete, the order processing service it will send a command to payment service. When the payment service responds that I have completed the payment, then the order processing service will send a command to the notification service, notify customer service. So that is how the Saga orchestrator is being the central coordinator amongst all these microservices to ensure that a distributed transaction remains consistent and is able to give the correct output at the end. Now let's understand how choreography pattern differs from Saga pattern and how to implement Saga pattern with choreography. So in the last one, we saw there's a central orchestrator and all the microservices interact with each other using the orchestrator. In choreography pattern, it's a bit different. Instead of a central server, there's a message broker, and all these services interact with each other via this message broker. All these services send events to this message broker and receive events. So each service emits event upon successful completion of a sub transaction, and if there's a failure, then a compensating event is triggered. And all these services know how to interact with each other, and they know how to trigger a respective sub transaction accordingly. So as we can see, there are multiple events. All these events are being sent to the message broker, and the other services are consuming it. And the central component is called as the choreographer. This was how Saga pattern is implemented using a choreography. So instead of commands, so how these two differ is in orchestrator pattern, there was a command that was sent from the central service to all the services, and they were responding to the coordinator service, the orchestrator. In choreography pattern, those commands are replaced by events. So every service subscribes to an event, and every service sends event. So whenever an event is sent to a service that the other microservice is listening to, they perform a sub transaction. Now, which one to choose? Whether to choose orchestration saga pattern or the choreography saga pattern. So it boils down to our use case. There are a couple of difference that these two design patterns have, and based on our use case and the requirements that we have, and our cases that we have, we need the complexity that our system is going to have, we choose one of these. So there are a couple of differences. The differences between these two, like the control flow in orchestration pattern, there's a centralized control that is maintained by an orchestrator. In choreography, it's decentralized. Coordination happens via the orchestrator. In choreography, services communicate directly using events. There is a high coupling in orchestration pattern. The coupling is pretty low in choreography pattern. Orchestration pattern can become a performance bottleneck as the system grows, because it will become difficult to scale this design because there will be a central server responsible. In choreography saga pattern, it will be better to horizontally scale because there's no problem. Each of the servers can be individually scaled. Fault tolerance. Again, in orchestration pattern, the orchestrator becomes a single point of failure. So that can be one trade-off to choose from. However, in choreography, it's better fault tolerant. It's isolated. Failures are like if one service fails, that is the only service that fails. Orchestrator handles the compensating transactions in the first one. In choreography, each service handles its own compensating actions. Again, there's no single point of control. Monitoring, in monitoring also, like in orchestration pattern, there's a clear flow of execution and easy monitoring that can be done. However, in choreography pattern, the it's more challenging because it's more challenging to monitor the overall transaction flow. And again, the complexity. Orchestration pattern is more suitable if you have a complex set of transactions that you need to cater to. But in choreography pattern, it will become more complicated because there it deals with events. So we'll have to keep a mapping of all the events, which might get complicated. So that's all for today's video. If you like the content, do let me know in the comment section below and like the video, and also subscribe to the channel because there are more videos to come. Thank you.